You ever found an API that shouldn't be live but is? That's either a shadow or zombie API, and they're a bug bounty goal. It is how. Let's first start understanding what is shadow APIs. So these are the APIs that developers deploy for testing, internal use, or to ship features fast, but they never get properly documented or registered with the security team. This means there is no monitoring, no logging, and no security review. They often skip important things like rate limiting, auth checks, or proper input validation because nobody even knows they're live. For bug hunters, this is prime territory because shadow APIs can expose sensitive data or critical business logic without anyone noticing. Most of the time, the shadow APIs doesn't have any access controls at all. So, let's take an example. A dev spins up an endpoint for a new mobile feature, and the endpoint is /API/preview/user data, and he did that for the purpose of testing. Now the QA misses it. It never makes the docs, but it stays in production. Now you find it in the wild with no authentication. Jackpot. You have found an API that is vulnerable, and you can report it. Now let's talk about zombie APIs. Zombie APIs are old endpoints that were supposed to be shut down but never were. Maybe the app upgraded to version 3, but version 1 and version 2 are still sitting there fully functional. So basically they forgot to remove it. Why is that bad? They often use outdated logic, they have weaker or missing security controls, and nobody's watching them anymore. So this is actually obvious because if an API endpoint was upgraded, means there was some vulnerabilities present in the previous version. So the previous version shouldn't be available, right? But it is, and you found it through your reconnaissance or while exploring a web application. So basically, they're called zombie APIs because they're dead, but from a dev perspective, very much alive for attackers. For example, a site now uses token-based auth for version 3, but version 1 still uses session-based auth and doesn't check permissions correctly. That's a perfect spot to test for IDORs, mass assignment, or sensitive data exposure. Now that we know that how both of these are different and so important to look into, and why they exist in the first place, let's see how you can identify them while bug hunting. To find zombie and shadow APIs, you have to first start with asset discovery. This is the process of finding everything a company owns that's connected to the internet. That includes domains and subdomains, IP addresses, server and APIs, cloud buckets, mobile apps, like that. So in this case, I would suggest you to start finding all the subdomains, IP addresses that are connected to a particular target. You can use different kind of asset discovery tools for that. One of the popular one is, which every one of us has heard of, is IMAS, which will also give you number of IP addresses that you can scan using Nmap. So maybe you can find some old services or applications that are running, and it might have some old APIs that are not being used, where you can do some more exploring. Type IMAS, you can see I have it installed. There are different versions of it, but in this case we are going to run the command enum because we want to enumerate, and then -d to provide domain name. Let's say tesla.com, and then you can also save it in a file, but right now I don't want to save it, so I'm just going to run this command. It does take a lot of time though. Another amazing tool I will suggest is Recon FTW. So let me go to the Recon folder. Why this one is a better option? It's because it already has IMAS and also a number of other subdomain discovery tools. So if you don't want to perform attacks and do nuclear scans, you can just use this command that is going to find all the subdomains using it. Different number of subdomain or asset discovery tools and give it to you. So you can use this command, or you can use this command, just do the reconnaissance app. Just give me the file of it. I don't want to run any nuclear checks on it or any kind of attacks. So I think this is a really good option as well. More good option than IMAS, I would say. So you can try it out. Now let's see some of the dorks that you can use to help your reconnaissance better. you can use this Google Doc. So I'm going to find all the subdomains or URLs that have /API in it for this particular target. You can choose any target, of course. So it's going to give you related subdomains. Also, not just /API, you can also look for swagger.json. So it depends on the target. It doesn't have any URL like that. That's why it's not giving me any result here. If you want to find all the subdomains but you don't want to include www, you can just use this dork #www. So it will get rid of all the domains that have www.paypal.com, and it will give you only subdomains. So now you can see more better results like sandbox.paypal.com, developer.paypal.com, and others. Well, most of them I'm seeing developers, but again, it depends on the target. So if you want to find documentation related to a particular domain, you can add this in title API documentation, something like that, or docs/docs as well. So you can try multiple keywords and it will give you documentation related. So as you can see, here are some URL that has words like docs in them. That's why it's showing us the results. Again, you can use something like that in URL API. So let's type amazon.com. And it will give you different subdomains of Amazon. Right now we are seeing the documentation that has the API words, but you have to just scroll and look more into it. Again, it depends on the target, what kind of target you're hunting on, because choosing a target is itself one of the crucial steps of bug hunting. I'm just using these targets for demonstration. To be honest, I don't hunt on Tesla or Amazon right now, but yeah, I just want to show you some of the dorks that you can use while hunting. Let's move on to some Shodan Dorks. So for Shodan, you can use a dork something like this. Type the organization in which you're looking for. It could be Amazon, Tesla, or whatever, and then you can type the HTTP title. So it's going to show you all the domains or subdomains that have HTTP title API in it for this particular organization. So if you look at the results, you can see somewhere or another all of these have API in it. It helps you filter out the subdomains that you want to look for. It can also contain third-party services that might not be in scope, so that's up to you how you make your decisions or choose the subdomains that are in asset. So keep that in mind. I just want to show you what kind of results you're expecting when you look around in Shodan with this dork. So as you can see, it's showing me all kind of API services here, different subdomains. I think these are hosted in Amazon Web Services. That's why it's showing me that, whether it's Amazon actual subdomain or not. Not sure, but yeah, you get the idea. Another thing you can do is you can look for Swagger files, because we know Swagger file contains the API collection. So you can type Swagger like this. So now we can see all the Swagger files. Again, you have to filter through them and try to identify which one is worth looking for. Okay, it's also showing us some LLM API. Okay, let's move on to next Shodan Dork we have. It is http.html GraphQL. So it will help you find GraphQL endpoints. Okay, now we're getting some weird results. If you see something like GraphQL Playground, then it is something of more interesting. To see what's going on. Let's open it up. So yeah, as you can see, this is the GraphQL Playground, and you can type query and mutation here and see what kind of response you are getting. Let's go back. And we have GraphQL as well, which is also another common. Also, if you don't want to use org, you can use host name. So if you want to provide a particular domain like amazon.com, but we didn't got any results. But as I said, it again depends on the target. So now that we have seen some of the Google and Shodan Dork, let's go back to the terminal. Well, we can see that we got a lot of subdomains here. So once you get all the subdomains, as I said, I didn't save this file, but let's say if you saved it, you can pass this to httpx to find what are the live subdomains, and then you can use grep command to find subdomains that have API in it, or that has stage in it, or any subdomain that has dev in it. So these are some interesting subdomains that you can look for. Another way is to find endpoints in the JavaScript files. JavaScript files are really important. I recently reported a bug in which I found a secret in the JavaScript file, and they provided me bounty for it as well. So I think it is something you should really look for. Before, I didn't used to look for JavaScript files much, but I realized that it is worth looking at. It reveals a lot of things. Even if you're not registered or logged into the application, and if you analyze the JavaScript files, you can see all endpoints laid out in front of you, how they're working, what arguments they require. You can also sometimes find admin endpoints, and you can try those endpoints and see if there is any authentication in place or not. So this is something very important. You can use tools as well, or you can use the manual approach. For example, let's say I have this tesla.com. I can just go to inspect here, and in debugger I can just look at the JavaScript files over here. So you can see there are multiple JS files, and you can do this, or you can search for keywords here like admin or secret or API. So it does require a lot of time. The bug I reported, I found that bug while manually looking into the JS files, but this thing can also be automated using tools like link finder or JS parser. And if you don't want to use link finder, you can also use GAO. You can provide your subdomains list to GAO, and it will try to find all the JS files related to it. So we found all the subdomains, but we also have to find which one of them are live, because those subdomains are going to give us JS files. If there is nothing in it, then we are not going to get JS files, right? So once you have that list, you can use a command like this. Let's say you saved it in output.txt file, and this file contains all of your subdomains. You can pass it through httpx. In my case, this is the command. You can use match code 200 to get all the URLs or subdomains that are live. Once you get all those, you can pass it to GAO, and GAO is going to find all of it, like all kind of URL endpoints in it, but you want to specifically look for JS files. In that case, you can just add another command, grep and then .js. It will give you all the JS files related to those subdomains that we just found earlier. So you can try out this command to automate it. Another thing that I want to talk about is parameter fuzzing. Because some of the APIs are using newer versions of the APIs, and the older versions of the APIs are vulnerable, but they are not removed from the web application, which is the case of zombie APIs, right? So in that case, if you have found API endpoints, or even when you are analyzing the web application and you are playing with the HTTP request and responses in your Burp suite, just try changing the versioning of the API. So if you see version 1, try changing it to version 2 or /beta and see how the server respond to it. Like that, you can also find vulnerabilities. Maybe the old version will give you extra information, like which is not necessary. So it requires a lot of analysis and some of your manual effort as well. Don't only go fully automated. But yeah, that's the things I wanted to cover in this video. If you have any more questions, let me know in the comment section, or if you want to add something as well, that you think is more interesting and other people will get help from it, you can add it in the comment as well. So thank you for watching, guys. I hope you enjoyed this video, and I'll see you in the next one.